All right, after about 3 hours, I don't know, 4 or 5 different configurations building the blocks, the model for this exhaust header, I think I finally got it. You ready for this? Let me show you what I got. Here it is. I got this motor up in the air, ready to lower back into the chassis so that I can work on the headers and get those modeled in. But one of the things I figured I would show you, I forgot to do this initially, the modification I had to make to the OEM engine mounts. So this is obviously the passenger side, and this cast aluminum engine mount, I actually had to relocate the actual mount on the bracket. I had to go inward, as you can see, about 1.5 inches. The original hole, bolt hole, is right here, so this dynamic engine mount, which electronically it'll firm up based on demand or how aggressive the engine rev is, or soften, at idle or cruising speeds. I had to move it inward by about 1.5 inches. So fortunately, there was enough room to relocate the hole and then slide, in the way this adapted to the bracket, slide it in about 1.5 inches. So drilled a new hole, had to machine out just a bit of cast aluminum there to make room for the bolt. And then I had to trim, you could see this edge. I had to trim, I don't know, maybe 1/4 inch off the edge of this, just so it would slide down past the frame rail, as it was just a little bit too wide. On the passenger side, no modification necessary. So passenger side sits a little narrower. It's not as long or as wide on the passenger side. It sits a little narrower anyway, so I didn't have to do anything on that side. By the way, you can see I've already got the first row of modeling blocks in there ready to go. Figured I would show that to you while I had this up in the air. Cool thing is I can reuse the factory heat shield as well. So anyway, that's that. Now the other thing I'll mention here that I learned, again, I've not done this before. This is my first time, so I've been searching on YouTube and anything I could find to help me learn how to build a set of headers like this. The other thing I learned that's really important is, as you start, once we get to cutting actual stainless steel pieces and bolting or welding them together, is fit up. And to get good fit up, you want to make sure that every piece is absolutely square and smooth on the top. So that's why that belt sander I have is so important, because you can sand it till it's absolutely straight, so that when you start to fit pieces up, there's literally no gap in there. And with no gap in there, you can do quick tack. You can make a really nice small profile weld that'll be strong and look good at the same time. So that's the one of the important lessons I've already learned is, as you're cutting, make sure you cut square and that you sand, and make sure that your mating pieces are absolutely 100% flat. The better the fit up, the easier it is to weld, the cleaner the weld, and the more quality the whole thing will look and perform when it's all done. Now the other thing that this kit came with are these, what are these called? I don't even know what these are called. They're basically starter brackets, starter braces, starter plugs, whatever you want to call them. You put this plug in there, you tighten it down, and it compresses the rubber and pushes out to hold it in the tube, in the starter tube. And then once you have all of these in place, that gives you a nice solid foundation to start clipping in your blocks. You simply slide your first modeling block on, reach through, tighten it, and then it secures the block to the tube nice and snug and firm so that you can start building off from your pieces. So that's the other kind of cool part of this kit to help you get started and help these modeling blocks get in place and stay in place while you're building this out. So I've already got a few modeling blocks on the header flange. You can see again, pretty tight right here. So I think I'm going to have to take this first runner and go back a bit and then loop it around. The rest should be pretty straightforward. Again, now ideally I'm going to try and make these runners equal length. So the length of them leading up to the collector here, all those runners would be equal length. I don't know how hard this is going to be, but we're going to find out. I've got this piece of tape right here to mark kind of the edge of where this flange is going to go. And then once I get closer to mating it to the end, I'll figure out how to get this secured here temporarily. But that's about where it's going to go. Clearance between the head, angling towards the center of the car a bit, so that it'll make it easier to fabricate the exhaust from there. That is the plan. Let's give this a shot. All right, here's round one of the model. It came out okay. I measured and marked, so top number is the number of 1-inch segments. Bottom number is the cylinder number. So I basically got, the longest runner is 28 inches, followed by 24. Then down there, number 1 is 22. Number 5 is 19, and then the shortest one is 15, number 4. So don't know if I'm going to be able to make these equal length or not. 28, or the number 3, this one here, I can definitely shorten a bit. 24, so cylinder number 2, I could shorten this one a bit. So I think I could get close, 20 to 22, 23. So maybe within 10% variance of each cylinder. But I'm going to have to redo this again. I forgot to install this. This is the heat shield that goes on the side of the head. And I can't fit it in there the way that is. So I got to take these runners apart, make sure to remember to reinstall that, and then try it again. I knew it was going to be a little bit of trial and error, so we'll get this heat shield on and go for round 2. there it is. Current design. I'll tell you in a minute what I ended up with for header lengths, runner lengths, trying to get them as equal as possible. I just have this collector propped up there with a zip tie and a piece of block under there just holding it up, but it could stand to come out this way just a hair to line up perfectly straight with the runners. But you get the idea. From a clearance standpoint, until I've got some rags again propping this up, that collector adds some weight to these blocks, and I don't want them to come undone. But I've got a rag here as a spacer, a rag over there as a spacer. I don't know, that's probably a solid inch, over an inch anyway, of space between that, the bottom runners and the rail. Some good clearance there for space. And then so when we get back here, it's good clearance here. I'm trying to keep as much away from the tank, the top of the tank, as possible. And I think what I'll end up doing is just getting some aluminum shield and cover this entire triangle piece so the tank will have double protection from what I already put on the tank. I ended up modifying the OEM heat shield. I just bent it up. I have to bend this corner still a little bit, but just bended this lip up to give some extra room. I think that does the trick. Came out pretty good. I angled that collector inward because I'm going to probably cut this a little shorter, start an elbow here, run it in. I'm probably going to do a crossover X-pipe before I then curl it back to the exhaust. That's what it looks like. Pretty cool. Came out pretty nice. And I think what I can do is if I just mirror this configuration for the other side, it's a puzzle, that's for sure. Trying to figure out how you're going to get these in, get them routed. So here's where we ended up on runner length. The numbers here, 1 through 5, that's the cylinder number. Starting with number 1, that's 16 inches long, 23, 20, 20, 22. So pretty dang close, except for cylinder number 1 is the shortest. It's short by 20% of the median, which is 20 here. I set 20 as my marker since I have two of them right nuts on 20 inches long. One at 22 inches, which is plus 9% in length. One at 23, which is plus 13% in length, and you get the idea. So I think I'm going to call that good. I was looking at a way to maybe make this number 1 runner longer, but man, I just don't think it's worth it. I think the way I've got this, it's compact. The heat is the maximum heat will be right here. And so there's space from the fiberglass. It's up away from the tank as best I can. There's a heat shield here. And then, like I said, I'll add a heat shield underneath as well. So, and then I'll add, again, this will come out this way, probably maybe an inch as well. And then I'll do a heat shield in between the head and the exhaust right there at that spot as well. Probably just extend this around the corner. Anyway, I think that came out pretty good. I'm pretty happy with it. So that part's done. The hard part now, I'm going to try and remove this all as one piece, as one setup, and then take apart each runner one by one and then start manufacturing the steel version, the stainless steel version of each one of those runners. And I'll show you how that works once I get to it. Anyway, let's keep it rolling. All right, guys, let me show you how these modeling blocks work. These are the modeling blocks. The key to them is these indexing points. That's basically the radial axis that you want to align here. So these things all interlock. So you simply line up the arrows, give it a click. You want to try to do as many sections with these arrows aligned. That will minimize the number of cuts you need. But then, of course, as you're designing the system, if you need to clock these, you can rotate them to configure your header system. But just keep in mind, as soon as these indexing marks become misaligned, that's a place where you need to cut, where you have to cut your your U-bend to make a joint. And this would obviously be a weld joint right here. So to minimize your weld joints, you want to do as many of these pieces as you can fully indexed. Okay, so as you're making a bend, just keep these indexed and try to keep the number of times you clock these offset to minimize your bends and to optimize your material. So that's pretty much how that works. Now let me show you in what I ended up with on my measurements here. And what you do is you just count up the number of blocks and fill in the pieces that you've used in your model, and then that will give you a shopping list of what you need to buy, so that you're not buying too much or too little. Here is my worksheet. This is for the driver's side. I basically marked out, so say for cylinder 1, you see there's, let's see, A, B, C, D, E. So there's 5 sections of cylinder 1. And you can see where I'm going to have to cut. So this first section, 1A, this is at the header flange. So we go from the header flange outward all the way to E. So I've got a small straight piece and then 1, 2, 3 2-inch centerline radius pieces cut together. So this is one piece that I will then cut from this U-bend. And then I get to make a turn, so I got to clock the material. So here's 1B, here's the second set. So it's 1, 2 pieces, and then a straight end there. And so that will be the second piece I weld on, and so forth as we go downstream. Then C, then D, then E. So number 1 cylinder is the worst because it's got this funky bend in it to get it out from around the frame rails. So that's the only piece where I've got 5 sections. The rest of them have 4 sections. Cylinder number 5 has the widest, a 6-inch CLR, nice wide bend there. When I come down here, you can see that's actually the second section, 5B, this big radius there. 5A, first piece coming off the flange. Here's 5B. Another bend, then 5C, another bend, 5D is right here, and that's the last piece. That's this straight piece that goes into the header. So that's how that works. It's pretty cool. Now from this, I can calculate what I need to buy. For this, it looks like I have to buy 1, 2, 3, 4, 5, 6 2-inch CLR pieces, 1, 2, 3, 4 3-inch, 1, 2, 3, 4-inch, and 1 6-inch. That's the pieces I'll need. Then multiply that times 2 for the other side. I'm going to go ahead and order this material up, get it shipped hopefully next week, and then in about a week's time, hopefully you guys will see another video with me cutting and welding this thing together. So pretty exciting.